In this video, we're going to look at how to create different histograms for quantitative variables using R. So before you start this video, a couple things that you'll want to have is you'll want to locate the Kentucky dataset, which is located on Canvas if you want to follow directly along with the video. You'll also want to find the file. It's called module6_R spring 24. This is also located on Canvas right above this video that you're watching. And then the other thing you'll want to have handy is the code book for the BRFSS dataset. All right, so the very first thing we're going to do is we're going to read in that dataset that we created in Module 5. So if you'll remember, in Module 5, we read in a reduced version of the BRFSS, and then we further reduced it to only contain data for the state of Kentucky, and then on your own, you created a dataset to only include the data for your particular state. So I'm going to read in that data set. Remember that when we read in a data set, the first thing that we want to do is set our working directory. If you're working out of the same folder on your computer as you did in the last video, you can just copy and paste that set working directory line into this file. If not, as a reminder, how you can find it is by clicking on the Files tab here in the bottom right-hand corner. Click on the 3 horizontal dots. This will open up the directory on your computer. Remember, this is only going to show the folders, not files. And then you could navigate to where on your computer you have those files stored. Clicking open, you should see your files here. If you don't see the files pop up here, then that tells you you have the wrong place. All right, once you have that, you can click on More, Set Working Directory, and that line of code will appear here, and then you can always copy and paste it up here. One thing to notice is when you're copying and pasting your code, make sure that you do not copy that first character. All right, the next thing I'm going to do is, now that I've told R where that file is located, I'm now going to read in the Kentucky data set. And again, notice we can see the Kentucky data set or KentuckyData.csv right here. So I'm going to name it Kentucky Data. I'm going to use the left arrow and then the read.csv function to read in that CSV file. So notice what this is going to do. It's going to read in the Kentucky Data CSV and create a data set in R called Kentucky Data. The Kentucky data set now appears up here. There's a couple things that we could do to kind of check this file to make sure everything read in okay. I can see this data set has 2,869 observations with 18 variables. That's the same that we saw last time. If we click down, we can see each of the variables that's included in this data set. Just as a reminder, remember in the BRFSS, several of the variables start with an underscore, and R will automatically put an X in front of that because it won't allow variables to start with an underscore. If we want to view the data set, there's 2 different ways we could do it. We could use the view function, and notice this is a capital V with the name of the data set in the middle, and that will bring up our data set here. We could kind of scroll through and look at some of those different variables, make sure nothing looks strange. One thing to notice here is anywhere you see an NA, that just means that the value was missing. So for example, for this person represented in the first row, they are missing the value for this particular variable. They're also missing the value for these 2 variables. Okay, going back to our file here. So now we've read in the data set, and now that we've read in the data set, we can now make our histograms. All of the functions that we've seen so far in the videos have been part of what is called base R. So whenever you install R, you automatically get those functions. There are lots of other functions available in R that can do all kinds of different things. And some of those functions are placed into different packages and combined together. So we're going to use what is called tidyverse. Tidyverse is a group of different functions that can be really useful when it comes to summarizing data. So in order to use these functions, we do need to call forward the tidyverse package, and I'm going to show you how to do this. It is a 2-step process. The first step you only ever have to do one time. The second time you'll need to do each and every time you want to use those functions. So if you come up here to Tools, and you'll notice there is an Install Packages option. We're going to click on that. You're going to install from the repository CRAN, so make sure that is selected. And then we're going to type in tidyverse. And then click install. You're going to see several things happen down here. Don't worry that this is in yellow, that's perfectly fine. And now that package is installed. You may get a window asking you to select a mirror. If you do, just select one of the mirrors in the United States. Right? After that package has been installed, and again, you only have to do that the first time you use tidyverse. From then on out, the second step is to call library tidyverse, and this loads the package. And again, you'll see some text that appears. All of that is perfectly fine. And now you'll be able to use the functions we need to create histograms. So we're going to create a histogram of the phys health variable. This variable is located on page 19 of the codebook. You already took a preliminary look at this variable in one of the other worksheets. So the first thing we're going to do is just a couple preliminary checks for this particular variable to get a feel for what it looks like. And we have two different functions here. This first one right here is actually a combination of two different functions, the sum function and the is.na function. What this is going to do is it's going to look at the physical health variable, and it's going to go through and actually tell us how many missing observations there were for that variable. So if we run this, we can see there is one missing value. The next function I have here is the table function. Now we've seen previously for categorical variables that we might summarize a categorical variable using the table function to create a frequency table. But here what we're going to do is we're not actually going to create a frequency table to summarize for publication or anything like that. Instead what it's going to do is just give us a glimpse of that phys health variable. Now notice that the phys health variable tells us how many days the person had poor physical health. This is a discrete variable. It only takes the values 0 through 30, and then we have a couple other options that represent categories that you saw in the previous worksheet. So if we click this and we click run, and we look at our different values here, we can see in our data set there were 74 people with a 1. There were 123 people with 2. So in other words, 74 people in the data set said they had 1 poor physical health days. 123 people said they had 2 physical health days. And then we're limited here by the width of the screen, so notice these two rows really wrap around down to the next line. So there was one person that said 22 days, one person that said 23 days, and then remember that for this particular variable, the 77s, the 88s, and the 99s have a particular meaning, and so we have those recorded up here. Now, what this table allows us to do is it allows us to kind of have a view of some of those special responses that somebody could give. So for example, if there were zeros for this particular variable, the person replied, if there were 0 days of poor physical health, this was recorded as an 88. So we need to know how many days of poor physical health were 0 for people, or how many people replied that. So here I can see there were 1,815 88s. So what I'm just doing here is making myself a note of what these different special categories are. We can see there were 36 77s, and we can see there were 10 99s. And then also, if we scroll up, remember that there was also 1 missing value. So I'm just again recording that here in the comments. This is going to help me later on when I go to create the histogram. Now next, if I'm going to actually create a histogram, when I create that histogram, I don't want the 77s and the 99s to show. Because as a reminder, remember that the 77s actually represent a response of don't know, not sure, and the 99s represent someone refused to answer. Well, those are categories, so if I'm creating a histogram, I want to remove those first. And the other thing is, if I'm creating a histogram, remember that the 88s represent a 0. Well, in this case, I don't want to have those recorded as an 88 when I go to make my histogram. Instead, I really want those to be recorded as a 0. So what I've done here is I've used the mutate function to help me. And what I'm going to do is I'm going to make a new physical health variable. And every time that I see an 88 in the original physical health variable, I'm going to change that to a 0. And then I'm going to change the 77s and the 99s to missing, because those don't represent actual numbers. And so you'll notice what I have here is I say if phys health is less than 0, then I want, or probably is less than or equal to 30, I want to keep the original value. If phys health is equal to 77, I want to set it to missing. If phys health is equal to 88, I want to change that to a 0. And if phys health is equal to 99, I want to change that to missing. So we run all of this code. And now let's look at our new variable. So looking at our new variable, again, I'm going to use my table function to help me. So now if I look at the new phys health variable, I can see that it only takes the values 0 through 30. So we really did get rid of those 77s and 99s, and then we also changed the 88s to be equal to 0. Because remember that we had 1,815 88s, and now we can see we have 1,815 zeros. So we've just recoded this variable so that it makes more intuitive sense. And then the last thing I want to do is, since I'm going to make a histogram of this variable, I'd like to know how many observations actually go into making the histogram. So I can use this function right here. And so now I can see that there are 2,822 values for this new variable. And so in our full data set, we have 2,869 observations. But I'm only going to use 2,822 of those to make the histogram. So now let's actually make the histogram. So to make the histogram, I'm going to use the ggplot function. And so to use the ggplot function, what I'm going to do is I'm going to use that new phys health variable. And so let's go ahead and look at my histogram. So here is my new my histogram of that new physical health variable. You'll notice that we got a warning sign here. It says, warning, remove 47 rows containing 9 finite values. We'll notice that if we look at the difference between the 2,822 observations that actually went into making this histogram and the total number of observations in the data set, that difference is 47. In other words, it's telling you there were 47 missing values that it couldn't use to make the histogram. Right, a couple things about this histogram. Notice I've given it a title here that includes the number of observations that went into making the histogram. We have the relative frequency here on the left, and then we have an appropriate label for the x-axis. So if we look at this histogram, we can very quickly see that about 70% of people said they had 0 days where their physical health was not good. In other words, we had almost 70% of people say, they felt good every day, or their physical health was good every day. But if we come down here to 30, we can also see we had about 11% of people saying that their physical health was not good 30 days. So on pretty much every single day, they did not have good physical health. And then of course we have all the values here in the middle as well. All right, so that's how we can make a histogram of the physical health variable. Let's look at how we can make a histogram of the BMI variable. So this was a histogram of a discrete quantitative variable. Notice that BMI is a continuous, and so we can also make histograms of continuous quantitative variables. So again, just like we did with the physical health variable, we're going to look at the BMI variable and do some preliminary checks. Now, as a reminder, in the code book, the BMI variable starts with an underscore, so R is automatically going to place an X in front of it. So again, we're going to do 2 preliminary checks. we're going to go through and we're first going to look at how many missing values there are for this variable. We see there are 200. So let's make ourselves a note here. And then we could look at the table as well. So remember that BMI was a continuous random variable, or not random variable, but a continuous variable. And so it has lots and lots of options it can take compared to the physical health variable. So for that reason, if we make a table of BMI, it's not nearly as helpful to us for making a preliminary check as it was for physical health. The other thing with BMI is, remember, there's no values that we need to account for, like don't know, not sure's, refusals. Those didn't exist for this variable, so we don't have to worry about that. But one thing that we do need to worry about for the BMI variable was, if you'll remember, the way that it was recorded was it had those 2 implied decimal places. So, for example, if we had a BMI of 8,716, that was really a BMI of 87.16. So in this case, I am going to use the mutate function to create a new BMI variable, but I'm going to do it slightly different than what we did for the physical health variable. Here, in order to account for those 2 implied decimal places, I'm going to divide BMI by 100. So again, I'm making a new BMI variable. Notice I put underscore new after it. But to create this new one, all I'm going to do is take the original one, and I'm going to divide by 100. And so I'm going to check that new variable. Here again, I'm going to make a table. I'm going to know, again, there's a whole bunch of observations here. And so it's not terribly useful, but I can very quickly see that all those values now account for those 2 implied decimal places. Right? And so now I'm going to see how many actual values I have. I can see there are 2,669. And that makes sense because we know there are 2,869 observations total for the data set. For this particular variable, we already saw that there were 200 missing. So that tells me I have 2,669 observations for the BMI variable. And so now I'm going to create a histogram just like I did for the physical health variable using ggplot. You'll notice you get that warning sign, but remember that's just the 200 that were missing. And if we look at the histogram, we have a nice title with the number of observations used to create this histogram. We have the relative frequency, and we have a reasonable label for the x-axis. So that's how we can create histograms using R for both the physical health variable and the BMI variable. So I've went through these a little bit quickly and haven't shown you how to change them. So now what I'd like to do is we're going to pull up the assignment for this week to look at it and then talk about what changes you'll need to make for your submission and how you can create these plots for these variables for your particular data set. So again, the first thing I'm going to do is let's look at the actual assignment for this week. All right, so here is your software assignment. So for your software assignment, you're going to work with both the physical health variable and the BMI variable. And you're going to create histograms for both of these, but using the data for your state. And then after you create those histograms, you're going to place each of them in a Word document and then answer these questions below. So let's see how you can go about this. So located in Canvas, you will see an example script that looks like this. And so this is for you to fill in your R code used to produce your histograms, and you'll turn this in with the assignment. So the first piece of code you're going to do is read in your data set that you created in Module 5. And you should not be reading in the full BRFSS data set. Again, we're going to read in that one specific for your state. So after this first comment, what we can do is come over to the script from the video, or the script that we just looked at. And notice here I have a section called Read in Data created in Module 5. I want to copy this code, paste it in, and you'll want to make a couple changes. The first change that you'll want to do is change this working directory to be where on your computer you've saved the data set for your state. And this may be a data set that was further subsetted to only include males or females as well. Next, you're going to read in that data set. So the two changes you'll need to make, it'll depend on what you named the CSV file that you saved, but for most people, you've probably named it using the two-letter abbreviation for your state. So for example, I think in the last video I used Florida. If you're working with Florida, you probably named your file FL_data. Or again, if you were restricting this to just be males or females, it might be like FL_M_data. And then you'll want to give it a new name that you're going to use here throughout the script. And so this will be what R is calling the data set. So I've called it Kentucky data. Again, you could call this, whatever you want to with the abbreviation for your state. And then you'll want to view the data set to make sure everything looks good. So these are the only 3 lines of code you need to read in the data. Next, you'll want to make a histogram for the physical health variable. To make this histogram, again, if we go back to the script from the video, you'll want to copy all of the code for the physical health variable. We're going to paste that into this section, and then we'll talk about the changes that you need to make. So you will need to call in the tidyverse. So if you didn't do so while watching the first part of this video, do make sure to go up here to Tools, Install Packages, search for tidyverse, and then click Install. And then run this library line. All right, next you'll want to do those preliminary checks for the physical health variable. So the only change that you'll need to make in these 2 lines of code is you will want to change, instead of having KY data here, you'll want to use whatever you named your data set right here. So you'll just replace whatever you have here, and right here. No other changes are needed. And then, just like we did for the Kentucky data set, you'll want to fill in each of these numbers on these 4 comments to match what you see for your state. So line 29 is going to give you the number of missing values. When you run the table, you'll pull the number of 88s, which is really the number of 0 poor physical health days from this line in the table. The refused answers are the 99s, so you'll pull the 99s from there. And then 77, those are the don't knows, not sures, so you'll put that number here. Next, you'll make a new physical health variable, and what this is going to do is remove those 77s and 99s and change the 88s to 0s. So for this line of code, there are only 2 places that you need to change the code. You'll change the Kentucky data to be your data, and Kentucky data here to be your data. No other changes are needed for this line of code. You'll want to check your new variable. And so again, the only changes needed here are to change the Kentucky data set to your data set. And then you'll want to record how many values there are for that new variable. Then to create the histogram, the only changes you'll need to make for this pieces of code is you'll want to change the data to be Kentucky data. You can change the color if you'd like a different color. And then here in the title, you'll want to change n equals to, instead of 2,822, you'll want the value that you found for your state, and then nothing else needs to be changed. And then finally for the BMI variable, again, you'll copy the code from here, paste it into this section. You'll want to change the Kentucky data to be your data set, record how many missing values you find, change the Kentucky data to be your data set. Here, you'll put in your data set and your data set. No other changes are needed. This will create that new BMI variable where BMI is now divided by 100, so we actually have the decimal places that we would expect. You'll change Kentucky data here to be your data set. And again, we're just running this table to make sure that we do see those decimal places in the values. Change the Kentucky data to be your data set here again, and record the number of values you have for the new BMI variable in your data set. And then finally, to make the histogram, again, you'll change the Kentucky data set to be your data. If you would like to, you can change the color. And then you'll want to change this value right here to be the number of observations for BMI for your particular state. And so you get that number from up here. But other than that, you shouldn't have to make any other changes to make your histograms. Now, each time that you make a histogram, again, you're going to want to place that into the Word document. So how you can do that is once you have the histogram here, you can click on Export, and then you can click on Save as Image, and that will save it to your computer. You can also copy to the clipboard and then just paste it into a Word document. You can also use these arrows right here to toggle back and forth between the different histograms. So you have both of those available to you if you go through all of the code and then decide to make the Word document. All right, so if you have any questions about how to make these histograms for your state, please let me know. As I've said on Canvas, please keep in mind this is not a coding class. We are using code to make these different plots, but I have it set up so that you really just need to make minor changes to the code to be able to make the different plots and tables needed for your report. So again, if you have any questions at any time, please let me know.